Welcome to another Solibri webinar. Thank you all for joining. Today we have a very special guest, Joe Magas, and we will be together talking about MEP coordination with Solibri. Very interesting topic. I'm your host today. My name is Maya. And together with me, John has joined us, and he will be answering all of your Solibri related questions. So today we have dedicated some time for your Q&As. So at any time during the webinar, if you have any questions, please drop it in the chat. And I would like to ask you to say whether this question is for Joe or for us at Solibri. This will make things so much easier for us. Yes, our subject today is finding the middle ground, improving MEP coordination with Solibri. But before I give the stage to Joe, we have some questions for you that we're very curious to know. So I will start some poll questions, starting with the first question. So what is your role in the MEP project? Is it an architect or an engineer or even a contractor? And if you cannot find the option in between those options, so please feel free to write it in the chat if you cannot find it. All right, I see that most of our audience today are architects. I'll wait for more of you to vote. Okay, and I'll share with you the results. It seems that a lot of you with us today are architects. We also have some mechanical engineers and contractors. Also, small of our audience are structural engineers. Welcome all. It's great to meet you. We have two more questions, and the second question is, what are the largest challenges in MEP coordination? So please let us know what are the most challenges that you face during your projects so that we can address it properly during the webinar. And if you have any other challenges, please write it in the chat. Okay, we have more votes for this question. Interesting. It seems now that most of the votes are going towards low quality BIM models. All right, let me share with you the results. So more than 41% voted for low quality BIM models, but it's interesting that 28% thinks that poor communication are the biggest challenge, and also 25% finding issues too late. So that's something to discuss with Joe very soon. All right, and one more final question regarding how much of your time do you think is lost to poor MEP coordination? Oh, wow. We have a lot of votes for more than 20%. It could be very frustrating, for sure. That's why we're here to discuss this topic. Okay. Thank you for voting. All right, and here are the results. It's very interesting that most of the results think that a high percentage is going towards poor MEP coordination. What do you think, Joe, about these results?
I am a little bit surprised as to how high those numbers are, to be honest.
Mm-hmm.
It's there is often between mechanical and architectural, those are the two disciplines that really have to coordinate the most. So that one didn't surprise me. And I'm glad to see many architects and engineers, especially mechanical on the show. But yeah, this surprises me. People are saying they're spending more than 1 day a week just messing with this.
Wow.
Just think about
Wow.
that. Wow.
All right,
Yeah.
then that's the more reason to get started with our subject today.
Yeah, you better stick around.
Yes. Okay, I will give you the floor, Joe. Thank you so much for this opportunity.
Thank you, Maya, and thank you, John, for backing me up here. So my name is Joe Magas. I'm based in Western Canada. Little side note, we've had gray skies here because of smoke for days, but we had a nice rain last night, so the skies are blue. So yeah, always trying situations sometimes in Western Canada with fires. But yeah, I'm a Solibri certified trainer. I believe the first in North America, and my company Fusiontek, we help people succeed, companies succeed with BIM, VR technology. So here's my contact information. It'll be at the end as well. So hopefully you can reach out if you want to chat. All right, I think we're good to get into the meat of our discussion. I was trying to think about how to sum up this topic. Like, these are all amazing professionals, and they all have a common goal. And each of these professionals is dedicated. And so perhaps maybe when a project starts, everything's fresh and there's no mistakes in it yet. And it's kind of a beautiful thing to see. But even though all these professionals are highly skilled, they're often are only highly skilled in their discipline. They're not highly skilled if you're mechanical. You're not highly skilled with, say, in structural. Architecture needs to know a bunch of everything, but how can you know all of that? So as time goes on, even though they all have a common goal, conflicting priorities can come in. Structural needs something bigger, right? There we go. Mechanical wants to run their stuff, and there happens to be some structure in the way, right? Wrong location. Fighting for space. Is there enough? So electrical puts many devices on the system. Do we have enough? More space. And the worst of all, you missed it. So then what we see is that even though there's a common goal with highly skilled professionals, things tend to break, I would say, in the middle between them. That's kind of what I kind of wanted to graphically show here. It's not an architectural problem usually, and it's not a mechanical problem. It's usually an architectural mechanical problem. So the highly skilled individuals on either side are doing kind of great, but when they have to meet in the middle, that's where sometimes things go to an unhappy place. And then I have to pose this question because, you know, let's say 20 years ago, we were all sold that BIM was going to solve all of this for us. Was that not sold to us as we sat in our sessions, listened to the presentations? Yes, so many of us heard that. But it's not necessarily that this is wrong. It's just, for many, they haven't experienced this yet. And we're going to talk about what's missing. And what's missing is in the middle. So the problems are always in the middle. The solutions are in the middle as well, is what I would argue. So let's just take an example of how this is the case. How we could have BIM, yet we still don't have all of these problems solved. Think of it from an accounting data standpoint. You have all these receipts, all these invoices, different data sources, right? And someone in the company needs to have business intelligence, like, are we making money? Are we spending too much? Are we going bankrupt? Where do we need to change? So having the data and then getting the business intelligence, there's something missing in the middle, right? That you cannot determine if you're going bankrupt from this stack of receipts. What's missing in the middle is the ability to organize and classify the data and analyze it. So some people might use Microsoft Excel, Some people might use QuickBooks or ACPAC, or whatever the various accounting solutions there are. But a lot of what they do is that they take data and they sort it out, giving it classifications. This is a capital cost. This is an operating expense. This is marketing. And then from that data, now they can make smart decisions about their business. They have business insight and business intelligence. So I'm sure you'd agree that this is the case. Now, I would argue that it's the same case with BIM. We have BIM, and I know a lot of people think highly of BIM. That's excellent. But at a certain level, BIM is kind of unorganized. It's a lot of data in there. Often BIM files are large. They're hard to access. So there's some problems with it. It's kind of like a pile of data. But what we want is we want project intelligence from that data. We want to be able to say, okay, does it meet code? Are we missing anything? Is there enough? You can't determine this from the pile of Lego blocks. You just can't. So that's kind of where a lot of people are in this industry. We're stuck with the missing middle. And what is that missing middle? It's the same thing as with accounting. We need to organize and classify the data, allowing us to analyze it. Once we do that, we can make very smart business project decisions, and we can have project intelligence and insights. And we're going to show that today, breaking it down as simple as we can. Now, the secret sauce here, I would argue, is a combination of using a format called IFC and Solibri as a software solution. Now, perhaps you've heard of IFC. It doesn't get a lot of play in North America. People think of it as a second-class file format. You know, like I'll use IFC if I have to share with Tekla, you know. But we're going to see that IFC is one of the most remarkable technologies for getting insight into BIM, and Solibri is the best solution to do so. Let's take a look. So an IFC file is an industry foundation class. I would describe it as having a chocolate bar and removing the wrapper from it. And you still have the chocolate bar. So all the data and all the information, all the geometry gets transferred to the IFC, but none of the vendor specific, like none of the Revit or ArchiCAD or Tekla kind of goop. That's all left behind, and the data gets structured in a format that's easier for everyone to understand. At a very high level, I think of it as the IFC file is the BIM of the PDF of BIM. It takes a file, simplifies it to its essentials, allowing for more collaboration outside of the native software. Okay, so this very quickly, I just want to lay the foundation. If there's one thing we get from this presentation, is just how powerful IFC is for analyzing data. It's remarkable. So you have all these different BIM models. They come from various sources. They get combined into an IFC model, or multiple IFCs get combined in Solibri. And what you get is everything is better. Like you can't draw walls in Solibri, so that's not better. You still have to go back to your software. But everything for analyzing the project is better in Solibri than it is in your native BIM software. You have a single data source. You have smaller files, easier navigation, the ability to organize data. You can analyze it and produce reports. Let's take a look at an example here. What I have here is I'm in Solibri, and I've already added a couple models, the architectural and structure. Now, this project might be 10 gigabytes large in total. So just kind of keep that in mind. It might take you 2 or 3 hours even to open this file with all of its links in the native software. Maybe not 2 or 3 hours, but it could take you a while. But I'm going to add the MEP models into Solibri to create a combined model. And then we're going to analyze the data a bit. I'll just talk you through this. So the first thing I'm going to do is I'm going to click on Add Models. Even though I already have 3 models in there, I'm going to add 4 more. So this is real time. I did not edit this in terms of speed. So what we're seeing is real time, this data being brought into Solibri. And there we go. Once it's brought in, it's optimized, But now we can actually analyze it as well. We can isolate the different models within Solibri. And notice how fast the performance is. Might be a touch pixelated on your screen, but I'm just going to add various models to this display. All right. There we go. So now I have all the systems models. Now we don't add data in Solibri, but we can organize it. So I'm going to make something called a selection basket out of it. What does this mean? Well, it means I'm going to group these models into a single package that I can select and display and analyze, right? So right away, I've added more structure to the file, more organization. Notice when I click on any part, all of the metadata, all of the information from the BIM model kind of got brought over. In the lower left-hand corner, you can see what the manufacturer was, its location, its relationship to other things. So now what we're going to do is we're just going to actually just break it down even further. What if we just wanted to show, for example, just the space heaters? Well, look how fast you can get to that data. There's all the space heaters in the project, no matter what model it came from. Now I'll just create another selection basket here. But no matter where this information came from, it's all accessible in one file with one query in Solibri. It's a single database now. So now I can flip between my two selection baskets very easily. I can even Google a Solibri federated model. So any piece of information, like I just want to look for a manufacturer, and I can actually click in here and say, oh, show me everything that is from FlexCon. Now that was like a Google search of our BIM model. Now I'll just save that to a selection basket, just so I have that data later. Got to fix a little spelling mistake there, and we're off to the races. Okay. So what we want to take note of is how easy it was to navigate through the model, to see the data we need to see, to add some organization to it, and to deal with large amounts of BIM data at the click of your fingers. I know there's platforms out there that'll do it for you as well, BIM 360, but Solibri is deeper on the data side. But it's also very nice to use from browsing around, finding what you need very quickly. Okay, so what we're going to take a look at is getting back to our idea of everyone working together. What we wanted to show you is how easy it was to bring IFC data from an export from a BIM model into IFC, bring it into Solibri, and combine it. So now we're going to get back more to the people involved. So Christopher and Evan, they're both highly trained professionals. They both want to do the best job they can. Let's look at something that could come up between them that would be a coordination item that they'd have to work through. And let's see how Solibri could help them once again in the middle. So it might not be code to have a drain in every washroom, but this client might be sensitive. So Christopher might feel, well, did you remember to put one in every washroom? Evan, he's not sure what happened. Let me check. Thanks, get back to me right away. All right, and then here's the kind of the thought bubbles going on in their head. Boy, this has never come up before, and wow, engineers. But this is a legitimate coordination item between these two parties. It's not strictly architectural, because the architects put the washrooms in there, and it's not strictly mechanical. Mechanical provides drains, but you know, how can they determine they caught all of this? Well, they'd have to go onto the drawings and manually check. Someone would have to remind them to manually check, and then they'd have to go and manually check. And it's possible it might just get forgotten. How can Solibri help? Well, before we get onto the topic, this brings up another interesting problem, which is like some of the data that comes into BIM, like for example, the architect calls it, sometimes he calls it WC, sometimes he calls it a washroom, sometimes he calls it men's, sometimes women's. So in Solibri, sometimes we have to do something like classify the data or kind of organize the data, organize our lens that we put on the data so that we can say, well, these are all washrooms. I know they're named different things, but they're all washrooms. Of course, there's multiple ways to do it, but we're going to do it off the name of the room. So we're going to show a little example. First of all, before we solve the problem, is how do we find all the washrooms? It's the first problem we have to solve. How do we smooth out the rough edges from the BIM file that was created in a variety of methods? Well, we'll take a look at that video. So here we have, in this video, we have a small space. We have some washrooms. So we have a men's and women's. We have a mechanical room up there. We have a little water closet in there. I know it's a lot of washrooms, but I'm just trying to make my point. And if you look carefully, there are some drains, but it's easy to miss that. What I'm going to do is I'm going to build a classification. I'm not changing the data in the IFCs. I'm just creating a new pair of glasses so that I can look at it differently. So I'm going to basically consolidate all of these rooms into a single classification. It'd be similar as to taking a pile of receipts and saying these are all for marketing purposes, right? So any room that's named this way, whether it's WC, men's, women's, it is going to be considered, in my mind, a washroom. And then we'll solve the other problem. So we'll just keep going here. Now, once you create these for each client or each project, they're highly reusable, but you might need to tweak them on projects, you know. So it's not like you have to do this on every project. Usually you do this once and it might cover you for 90% of the cases. There we go. So we're just going to classify that not as washroom, but we're going to classify that as a mechanical room. Okay. Okay, perfect. And I'm going to classify a kitchen as well, although it's not needed right at the moment. Okay, so I actually did that. Now, the coloring I didn't quite get, so it's no problem. I'll just go back to my color and I'll basically say, because I want to visually see it. I don't just want it in the database to look a certain way. I want to be able to visualize the data. So all I need to do is just assign each of those classifications a color, right? All right, so let's just see if we can. There we go. So we have kind of our washrooms all picked up in the blue color. We have our kitchen and we have our mechanical rooms classified accordingly. Okay, so now that we've been able to find all our washrooms and mechanical rooms and smooth out the rough edges of the data coming in, now we're able to say, is there a drain in every washroom or mechanical room? Okay, so that's our next video. We'll just go here and we're gonna go here and we're gonna go into the place called the rule set manager. And what I'm basically doing is just gonna create a rule called the number of components in a space. So what it's gonna do, I can tell it, I need so many of these devices as a minimum or a maximum in this type of a space. Okay. So I'm just gonna find the rule, the name of the rule is that washrooms and mechanical rooms must have a drain. I'm going to say at least one drain. Of course, a person could create the same rule and say, I don't want more than two. You could use the same template for that. I'm just going to see if I can pause that there, because I use the classification of spaces. That's the one I just created, right? So do you see how I'm able to use the classification I created to say, tell me anything I classify as a washroom and allow me to look for the components in it. So I'm going to keep on going there. Now I have to tell what objects I'm looking for in that space. Okay. So what we're doing is we're going to say in that space, in a mechanical room, I want a component. Actually, I classified this separately, but however you do that, multiple ways to do it. I'm going to say 1 and I'm going to say 10. You kind of need to indicate a maximum. So that's a little thing I found with this rule. So obviously I'm not worried about the maximum. But it seems like I had to put it there. Now go back to my model and I run the check. And if you can believe it, it's as simple as that. So now I have 2 spaces that are classified as washrooms that do not have a drain. Now from there, I can do a couple different things. I can create an issue of it and assign it to someone. I can go and fix the BIM model, or I can communicate somehow to someone, whatever the project requires. Right? Now, think of this not just in terms of someone asked you to do this check, but what if you did this check on every project? So the time savings or reducing the liability that you might experience or the client might experience is significant with just having a little check each and every time you do a BIM project. Let's take a look at another example. We have the architect. So often coordination issues do affect the architect. Electrical, I noticed, was the smallest number of attendees, and often they can wrap their stuff around other people pretty easy. Like they can get into where they want to go. Less coordination, usually. But electrical engineers put in thousands of devices. What if they miss 1/10 of 1% of those devices? Well, that still could be dozens of devices that were missed. Right? So here's a case, the project's gone out, I need to create an addendum. And of course, Sarah's gonna get right on that. And there's also some problems mechanically, some stuff was missed mechanically. The architect's gonna take, instead of designing a project now, he's gonna take part of his day creating this addendum, getting information, consolidating it, sending it off, processing the paperwork, right? So maybe this is where that 20% is right here. So what are they thinking in the background? Well, Sarah's thinking, yeah, I wasn't happy, but we ran out of time because so many changes were made. I mean, so many architectural changes were made, right? What does Christopher think? Well, he's like, oh, I don't want to be here doing this, right? There's got to be a better way. So let's take a look at an example how we do a coordination between, and again, it's similar, but it's between electrical and architecture in this case. So we know we'll just search for one type thing, which is light switches. So when you walk in a door, do you have a light switch? I mean, is it possible to miss light switches? I mean, there's thousands of devices engineers put on, and on big projects, anything's possible, right? So how can we get Solibri to look at every single door and make sure that every single door has a light switch within 1, 2, or 3 feet? Yes. In the next example, we're just going to go to our rule set manager. We're not going to classify any data because we can just access the data through another means. So there's flexibility in how you do this, but we're just going to go right to the rule set manager and we're going to search for that. So we'll take a look at that, and we're going to rule set manager, and there is something called component distance. Basically, what we're going to use component distance, the rule template of component distance for is to say I want to know if the door has a light switch within 3 feet. So that might not mean that we need a light switch there. There might be a reason that we don't. But we're going to be alerted, and we're going to get the project intelligence off of the model to get the data so that we can make the decision as the designer. Basically, I'm just going to say the distance between these footprints in a horizontal method is 3 feet. Go here and I'm going to say I just want to know from a door what's the maximum component distance to a light switch. Now I'm just going to grab the data in a different way. This could be classified, but I'm just going to say one of, and I'm going to pick some very specific objects from our database. So I want a single pole, and I'm going to go to as well add 3 pole. Okay, there we go. Now I'm going to say I want it to be limited to the space, and only the minimum number is 1. That's it. Go back to my model. I can test this in real time. Go to my checking tab, and I'm going to run a check on our model. Right away, I have these on the second floor. I have 13 examples of that. Okay. So a person could do this manually. Now, who would do it? Would the architect do it? Would the engineer do it? Would both of them do it? You could, how would you normally get this? Well, if it's part of your review process that every building you submit this rule to, you're going to catch it on every single project, every single time. Okay. I just want to highlight something. There is something here. Notice that there's actually two rectangles there that shows the error. That's called the severity. We're going to talk about severity. Sometimes Solibri calculates the severity on its own with an algorithm saying, look, this light switch is really far away, and maybe the other light switch was only 4 feet away, so it's less severe. So sometimes Solibri makes those calls on its own. It's providing intelligence to you. Later, we'll also see how we can override that and control the severity. But think of the time savings just having this information on every single project, every day of your week. You're getting some of that lost day back, 15, 20 minutes at a time. Okay, let's take a look at another example. So mechanical, structural, lots of coordination issues. Of course, a person could argue it depends on whether the model is a design intent model or it's a constructible model. So that bears on some of this as well. Solibri can be used for either, but obviously you have to rationalize its use, whether it's a design intent model or an actual constructible real world model created perhaps by the contractor. But in any event, this is your typical too many things running through things scenario is structural and mechanical, right? So you've seen this before. Now, Evan's like, well, we got a lot of things that run through things. So he's kind of hinting here, is there a minimum size? Like, can we ignore things of a certain size? Okay. In our example, we're not going to ignore any size, but we kind of we're asking the question here. And Keisha's saying, I'm mostly worried about 2 inches or larger, but I would like to know about all of them. And please don't take offense. We're just trying to have some fun. It's like, oh, so picky, and it's like, oh, the nerve, So please, I hope no one takes offense. We're just, sometimes these things run through a person's head. But with Solibri, this is really not a problem. And here's where we're going to use that severity parameter to say, okay, I'll give you as a high severity anything 2 inches, but as a lower severity anything less than 2. The actual clash detection is very easy in Solibri, so we're going to add that little nuance to it. So we're going to go in here and we're going to say, okay, well, we have these 3 pipes here running through some kind of a structural wall. Okay, let's just see what we can do. So we have those 3 pipes there. So I go back to my rule set manager, and let's create a rule for this one. This is called the general intersection rule. So it's, if you're coming from Navisworks, you'll use this one a lot. It's just one thing running into another thing type thing, right? So we're just going to call it piping versus structure. Perfect. And now we're just going to click on that guy, and we're going to go views, and we're going to go to our parameters, and basically we're going to go from our walls, or our pipes rather. So any pipe is going to go through any. Again, you can get as specific as you want. I put walls in there. Oversimplified, you probably want other things in there. But now we're going to say for high severity, we're going to say that the pipe size must have a width that is, see what I did, greater than or equal to 50 millimeters. And we're going to say that for the pipe size, for a low severity, we're going to say that it's going to be less than 50. It's still going to report the data, but sometimes the person gets overwhelmed. So this, instead of shouting that there's a clash, this is kind of just speaking politely that there's a clash. So we'll go to checking, and we'll run that little check here. And we can, in fact, see that there's there's 3 things. 2 of them are high priority, and 1 of them, because it's so small, is a low priority. Okay. So there's nuance we can add to these things in Solibri that allows us to communicate better. So one of the problems in our poll talked about is poor communication. Well, here's where there's some subtlety. Like I say, when you communicate, there's always subtlety. A person can be very upset or they can be fairly calm, or somewhere in the middle, right? So when we communicate issues, you know, for example, tweaking the severity parameter or tweaking the conditions very granularly in Solibri, we can perhaps communicate in a more constructive way. For example, we could have also told it to eliminate or to not worry about anything smaller than, for example, 15 millimeters. It was inconsequential. So don't even give us the report on that. Okay. Let's take a look at another example here. Very simple. I changed my model, please update yours, right? But then it's like, okay, well, do you have a list of the changes? So then do people ask this anymore? Are you allowed to ask this question? Because it's like, this is just taken for granted, and I don't know if that was ever provided, you know? And it's like, already the architect's just thinking about something else. There's no answer, right? Here's the model. I got another appointment to get to. And she's like, oh, that's no problem at all. So even though you sent me 2 different models, architectural, I can get a full summary of what was added, modified, and deleted very quickly in Solibri. Then you might have this capability in other platforms you use, or you may not. So I realize this, you know, this does exist outside Solibri, this type of thing. However, it is very easy in Solibri. Just do a quick analysis of this, right? So let's take this project. I have a single project in here called Solibri Building. It's just the architectural model. So now what I'm going to bring in is I'm going to bring in a modified or the latest version of that Solibri model, and we're going to see what happens. So I'm going to go to my File tab. I'm going to add my models. Okay, so I added that. It brought in some rules. I'm just going to remove the rules that it brought in automatically. What I'm going to do is flip over. I just want to show that there's a change. You notice on the top, there's a change on the little structure on the parapet. So I'll go to my rule set manager. And in this time, I'm not going to take it from my library. I'm going to take it from something that was pre-built already. So I had already pre-built this for another project. Actually, it's in the sample folder. So I'm not going to build it from scratch. I'm just going to take what's there. So up to this point, I've been building from scratch. But here I'm just going to say, no, I've done this before. It's called model review. I'm going to take all of this and make it a rule out of that. And I'm not even going to modify. I'm not even going to modify the what I'm doing, and I'm just going to run a check on that. There we go, model review, and we have severity, and you can see if we go down to our results, 3 things were added. We can click on them and visually see them. 2 things were removed, and 22 things were modified. So once again, it's the speed of getting this information off the BIM data. If you tried to get this any other way, other than a process like this, it's kind of a road to madness. It could take you, well, you might never find all the changes really. This will find every single change between this file and the last. So very good for reviewing, no matter who's sending you files. For example, someone might say, hey, I worked on my model all week and here's the latest. And you could check it and see what they added and realize, no, they didn't do very much work at all because they were busy on other jobs. You could do a very quick analysis of how much work was done and exactly where using Solibri. Again, unless we put the data into a format like IFC, we can't do this very easily. So I'm just going to go back here. Okay, this is I believe this is the last example between the disciplines, right? So mechanical, they need room for their mechanical and electrical need room not to place their stuff so much as around their stuff, right? So it's the area around their stuff that's sometimes as important as where it's placed. So for example, there might be safety requirements or setbacks, we could say, or there could just be like no, in order to get my hand into the cable tray to add a wire, I actually have to be able to get my hand in there, right? So it could be not so much for safety concerns as it is for maintenance concerns, right? So instead of Evan always fighting to get his middle ground or to get the middle ground, he's just going to take the middle ground. So what if the mechanical engineer like Evan, he's like, Solibri is pretty cool. I'm going to make my own rule set that every piece of equipment that I provide, I'm going to have rules that determine what the clearances are. Okay. I'm not going to go crazy. I'm just going to stick to what's absolutely necessary, but I'm going to create my own rules because I know this equipment better. The architect perhaps might have some input on where to place it, but they may not understand all of these requirements to the same degree as the mechanical engineer, right? So instead of letting this be a reactive issue, like whack-a-mole, like wait for it to come up and deal with it, why doesn't Evan just do this ahead of time? So what he's gonna do is he's gonna create a rule set that ensure proper clearances. It's like, does the architect mind? No, because he wants the same thing as Evan wants. He wants the building to work. So then he says, I'll send them to you. So rather than relying on the architect, for example, to build this data, what if the mechanical engineer invested that 1 day a week that they're wasting right now into building some of these rules? He's like, finally, I've solved this problem. Everyone's going to stay clear of my stuff. And what does the architect think? That dude's pretty smart. So let's take an example of very simple models. We have 3 HRUs. One of them, and I was going to do, you can do multiple clearances here, but you can see one of them is just on the underside. We need a certain clearance to anything below it, and that ceiling is just too close. We could create another rule, which I didn't do, which is like the clearance is on the side, because I kind of put one really close to that wall, and you know, maybe it's a load bearing or demising wall, and we're too close to that wall. We don't want to be that close, right? But all I did in this example is I'm checking to make sure that anything below I have a certain clearance for that unit, right? And nothing can invade that. That's not only I own this, I own the object, I own the space around the object, is what we're saying. So let's take a look at this. So I have these guys here, and we're going to see HRU rather, and we're just going to make it. It's a very simple one. It's called just I guess it's component distance again. Yeah. So we'll just rename this rule. Okay, we'll take a look at our parameters. And again, a variety of different options here. In this case, I want to go directly below, and I want to just change this. You can see lots of flexibility built in. And I have to say, okay, there's a little error here because I'm saying allowed maximum distance, but I'll change that later because that's not really what I wanted. So we'll go here, and we're going to say, I'm going to say anything with this type name. Again, classifications could be used here, or we could simply, I'm doing it off the name of the item. So anything that contains HRU, that's an object that I'm going to track. Now what I want is, do I care what's under there? No, anything. I don't want anything in that space. And I think I go here and I realize, no, I think it's the minimum distance. So these little things do trip you up in Solibri. I didn't do that on purpose, but sometimes a person forgets. It's the minimum distance I need. We'll go to our model and we'll just run a quick check. Clearance below. That element, there's not enough clearance behind that. You can see the little dimension there in purple, showing us that there's not enough clearance below that I would consider safe or constructible or serviceable, right? So here's where we find the middle ground. Like waiting for the architect to do this might never happen. But if a mechanical built a rule set, they can send it to the architect, or they could run the check themselves. But I think in this scenario, sending the rule set to the architect so that the architect could actually run the rule and get that same analysis would be fantastic. Okay, so again, this is trying to get ahead of the curve, trying to avoid the whack-a-mole approach, dealing with things as issues as they pop up. It's getting ahead of it and it's solving it soon. Okay, so that was kind of all of our examples there in terms of kind of different scenarios in terms of how we could find the middle ground. Just on this slide, just a thought is that not only are we limited with, we're often limited not with knowledge, but with time. So let's say Evan is the senior structural, the senior mechanical engineer, but he doesn't always have the time to get to every project, right? So by him building a rule with his knowledge encapsulated into that rule, like we just had in the last example, we actually have a scenario more like this, where he can capture his knowledge in the form of a rule in Solibri, and then it can be applied on any project. So it could be applied on 100 projects in a single week. Whereas there's no one way that Evan could review personally all 100 of those projects. It could also be sent to the architect or other disciplines who could run similar checks. So remember, this is about saving time. Well, Evan's time is limited. Putting out fires is not a good use of his time. Let's leverage his knowledge, codify it in a rule, and use it on every single project. So here's my contention after those examples, is that you can find project happiness in the middle with Solibri. When we talk about project happiness, we just mean everyone getting back to that common goal, create an amazing building, obviously getting paid, but create a building that works, is free from maintenance or safety issues, and is successful for people to live in, to work in, or whatever they need to do. Coordination issues take away our happiness from the project, from the people, and it's distracting and troublesome. We want to eliminate that as much as possible. So it's my contention that Solibri will allow you to do that, because it's the solution that often sits in the middle of these parties. Now, primarily it's not a sales presentation, but we'll just very quickly, like, why Solibri? Well, it is simply the best quality control solution on the market. You might say, well, can't I do this in XYZ product? And the majority of what I've shown today, I don't think you can. Of course, it's hard to say categorically with everything, but Solibri is the best in class at finding these quality control problems. That I can say with, it's the best all over solution. Other solutions maybe can find, from what I've experienced, geometry hitting each other, but not necessarily understanding the data and not necessarily understanding things close to things or things within a certain thing. Solibri is very good at that. There are flexible licensing with Solibri. So with Solibri, you could get a network license that you can be shared. It can be perpetual, it can be subscription. So there's some flexibility there. So a company might not need 10 Solibri licenses, they might just need one. So just, that's something to keep in mind. And it's an excellent ROI. So if you think of what is the cost of a problem that doesn't occur, or what's the value of a problem that doesn't occur, well, even if it saved you that 2 hours doing that addendum, that's time that's saved and that's money that's saved. So the ROI of using Solibri is very high. The learning curve is not, it's not simple as such, but a person can be trained, have assistance from others to get exactly where they want to go. So I'd like to have my information shown here again. We help people to improve their BIM processes with Solibri and with other software. There's my contact information, and I guess we're going to go to our questions. Now you can ask this wonderful panel figuratively, or you can ask me, or we also have John who's backing me up here in the background if he's still with us.
I am.
Thank you.
Nice.
Hello, thank you so much, Joe, for this wonderful presentation. This was really great. We already have some questions or some questions in our chat, but let me take some time to remind you that this is now the time. If you would like to ask any question to Joe or John, then please drop it in the chat. And if you're listening to this recording or watching this recording, Joe, can you go back to the contact slide? So please don't hesitate to contact me or contact Joe, and I will take over the screen. All right. So we have one question for you, Joe. That does Solibri already have IDS tools for checking delivery data?
All right, see if John wants to take a shot at that.
Yeah, actually, that's something that's in the works. It's not going to be in the next version, but that is a hot topic. Yeah, it's something. It's a feature that's that our development is looking in closely. It's for a future release that's going to be in the near future. You can't do any forward-looking statements of the sort, but yeah, just keep an eye out for it.
All right. Thank you, John. We have another question. Can you get notified if someone updates their model or send a notification to consultants that your model has been updated on Solibri?
So one thing that gets confusing in the space, little Solibri is not a collaboration platform as such, so it's a standalone software. When you link the model in, you both import it and link it back to its original source. And you can tell it whether you want to update that model or notify you or prompt when that model changes, you can be prompted, or it can automatically update. So, but it's not a platform that you'd actually put information and you get a notification. That's how I would answer that question. John, do you want to give some more nuance to that?
Yeah, so Solibri has always been able to link kind of like reference files. So if something changes, you export an IFC. If there's a change to the timestamp or the date in the file, you can set it up to automatically reload the model. But we also have integration tools for CDs, so you can, for instance, connect up to BIMsync or whatnot, and pull that information there from ACC, BIM 360. Pull your information from there and automatically update it from there as well. So it's not going to actually, it will prompt you. I mean, there's a setting that if you didn't want to have the model load automatically, you can have it pop up a little thing that says there's a new update to it. But it's not really, as Joe said, a CDE type of platform, cloud-based, where the models do not get stored in Solibri, aside from just the SMC. That's the native file.
Can I ask you a question, John? Where do people store a lot of their models? Is it in Dropbox? Is it on their network drive? Are a lot pulling it from BIM 360 today?
I don't really have the numbers on what uses. There's actually our Solibri Society page. We actually did a poll on that. I can't remember what the data was, but you know, there's users of usually just using on their shared drives or ACC. But predominantly, I think that most of our customers are just sticking them in a shared location that Solibri can pull to their local machines.
Yeah, and the cheapest
nice thing also is that you know, it's highly compressed. If you do save off this model, it's kind of like the best of both worlds, where you bring in the models of the IFC, which are plain text files that are really bulky, but it compresses down in the software itself to a .smc file, which has 80% compression, so that you can send that off to another user using the free viewer if they want to look at your clashes. Or we do link up to other BCF, BIM collaboration format servers, such as BIM Collab, again, BIMsync, to allow you to push that information to your other parties to view up on the web.
All right, thank you so much. We have time for one final question. And if any of the attendees have any questions, please drop it in the chat and we can send you the answer offline later on to your email, so don't worry. So the question for Joe is, do you define clash detection as a strength of Solibri Office?
I like that question. It's very conceptual. I would not define it as a strength because that's kind of so easy of Solibri to do. In other words, clash detection is fairly basic on the scale. So I don't define it as a strength. Of course, the reason I don't define it as a strength because it just does it so well.
Mm-hmm.
And there are other solutions that do clash detection. So the real strength, even though clash detection is all there and you have the whole thing, the real strength of Solibri is to access the data and to dig deep into, does this data exist? Is it correct? We didn't go deep into those kind of rabbit holes. To me, this is where the real strength of Solibri is. So it's strong, and it's even stronger is how I would define it. What do you think, John?
Yeah, pretty much the same thing as you said. There's just different, nuances of clash detections in a lot of softwares. Some of the nice features about Solibri is that as Joe showed you, that you can not just use the tolerances to ignore certain clashes, but you can actually, as he showed you, use severities based off of the depth of penetrations. You can manually do that, or you can use the radius or diameter of pipe. You can actually ignore them altogether. If a pipe runs straight through a wall or partition, you didn't want to see that, you can set those up. So it's just one of the features in the toolbox of Solibri that some people call a Swiss Army knife of things. So you have clash detection, which is just triangles running into one another. But as Joe showed you, a different handful of coordination checks, of distance checks, or whether or not something's actually in the room. It's one of the more of the features of Solibri is that it's a whole rule set of things and not just triangles running into one another.
Thank you, John, and thank you, Joe. Actually, we have one final question. We still have a couple of minutes. So, is it possible to add information into an ICF model, or in other words, to combine metadata from other models into the main file?
You want that
Want
one,
me to
John?
take that? I think that's basically what comes up a lot. This is more like along the lines of review software where you don't actually edit the IFC. I'm not sure if that's what they're asking. Basically, a lot of times people are saying, all right, we want to have something and we want to fix it. So the idea is that if you wanted to do something and put some data in, you'd use these collaboration tools like BCF Live or just send off those SMCs, and then they would go back into the actual native software to add that information. But you can add what Joe touched on was classification of water closets or men's rooms or women's rooms or whatever you want to call your toilet rooms, is that you can bring in additional information to make a more intelligent model within Solibri. But I don't know if you can really get that information back out. We don't really have a connection up to, say, Revit or ArchiCAD to then take that information and stick it back in. But
yeah, it's my understanding it's deliberately not there. In the same way that a PDF-based review process, you don't want, if an architect makes a floor plan and he creates a PDF, you don't want to change the PDF. So this breaks the fourth wall because if you just change the PDF, which you can actually do in Bluebeam, Bluebeam's got some cool stuff. You can change the PDF, but it's going to the problem is it's not going to update the model or the drawing. So, Solibri at this time, you cannot add data to a Solibri model. You can only reorganize it or look at it through different lenses. And it's almost purposefully stopping you. There's no ability to do it because you want the source data, you want the BIM models to be updated. You don't want Solibri to be editing the IFCs, is my understanding. It's to the thinking behind that. Does that make sense, John? Like, do you agree?
Yep, exactly. I mean, there's different thought camps of it. Some people don't want anything ever changed. They'll say, you come in, your model's not coordinated, something's off in space, and they say, well, I want to do this in Solibri. Some people say you should never do that in the review software. You should tell them to go fix it off in their actual native model. But you can do that in Solibri. You can move things around. But again, as Joe said, we don't change any of the information in there because it would just make everything inconsistent with what the actual design is supposed to be.
All right. Thank you so much. Thank you, Joe and John. I wanted to quickly announce to everyone that we are having another webinar. The next webinar is going to be on the 11th of October. So we will be discussing the automation, auto run mainly with Jonas. So please save the date and stay tuned. Thank you so much, Joe, for joining us today. Thank you for the amazing presentation. And thank you, John, for addressing most of the questions with Joe. Yeah, so let's stay in touch. And to our attendees, please feel free to contact me or Joe and John if you have further questions. Yes, have a wonderful day, evening, wherever you are, and we'll see you again in our next webinar. Thank you so much.